Alright, so this section is 4.8. I'm doing chapter 4 a little bit out of order, but you'll understand why after we get through all of it, okay? So we just finished simplifying square roots in the last video. We practiced that after your last test. Well, all of the radicals that we simplified had positive numbers under the square root, because until now you didn't know how to take the square root of a negative number. Well, that's about to change today. And here's where it starts. If you have the square root of -1, that is equal to I, which is an imaginary number. Okay, remember at the very, very beginning of this school year, we talked about the complex number system, and that was made up of real numbers and imaginary numbers. This is your introduction to imaginary numbers. So now, for the next line here, I want you to see how you get from this step to this. Okay? But one of the most important things you're going to need for the rest of this chapter is this concept right here. From time to time, you will also need this. Okay? So, if I take the square root of -1 equals I, and I square both sides of that equation. When you square a square root, they cancel each other out, and you're just left with the stuff underneath. On the right-hand side, you get I squared. That is where this statement comes from. Okay, it's not just made up, it's actually worked out by squaring both sides. So now, for problem number 1, they want me to simplify the square root of -18. Well, the first thing I'm going to do is rewrite that as the square root of -1 times a positive 18. So when I separate that, it looks like this. So now the square root of -1 is an I. And notice my I's are a little script I. It's got a hook on the bottom of it. And that's because if you don't and you can't see your dot, it looks like a 1. Okay, and it's important that we know it's an imaginary number. So square root of -1 is I. Now I've got to simplify the square root of 18 just like we did in the last set of notes. I'm going to break 18 down into a perfect square times another number. Well, 18 can be rewritten as 9 times 2. So when I take the square root of 9, I get 3. And when I write my final answer, I've got to write 3 then I square root of 2. Okay, you have to have your coefficient, then your imaginary, then your radical. It has to be in that order. So there is your answer. Now, for a complex number, here's your definition. A complex number is a real number plus or minus an imaginary number. Let's try again. Okay, and when I write the plus or minus, here's what it means, and this is the way your book gives it to you. It says A plus BI or A minus BI, with A being the real parts, the BI being the imaginary part. So sometimes it is written like this, and it's the exact same thing. It's just another format for writing those. So now, moving on to problem 3. We're going to talk about the sum and difference of complex numbers. Well, this is going to work just like other things that you have found the sum and the difference of. You're going to treat the I just like you would any other variable. So here's where we start. If I'm going to add this plus this, I've got to get rid of my parentheses. Well, what number is in front of each of those parentheses? There's nothing written there, so it's understood to be a 1. When you distribute that, you get 4 minus 3i minus 4 plus 3i, and now combine your like terms. 4 minus 4 gives me 0, and then negative 3i plus 3i also gives me 0. So my answer to this problem is 0. All right, let's try the next one. It's a subtraction problem, so it is a difference. I've got to get rid of my parentheses. There's no number in front of them, so they're understood to be a 1. Distribute here. I get 5 minus 3i. Distribute my negative. Gives me a plus 2 minus 4i. Combine my like terms. 5 and 2 give me 7. Negative 3i minus 4i is negative 7i. This is your complex answer. So now we're going to do one more extra one. This time I actually have coefficients written in front of the parentheses. So let's distribute those to get rid of my parentheses. Get 8 minus 10i minus 3 plus 6i. Combine your like terms. 8 minus 3 is 5. Negative 10i plus 6i is negative 4i. And that's it. Right, 2 more examples, and that's it for section 4.8. Okay, at least as far as what we're going to be doing. So problem 4 finishes up on the next page. They want to know what is each product. Well, product just means multiply. Well, this is a single term, which is a monomial times a binomial. You're just going to distribute. So when I multiply 3i times negative 5, I get negative 15i. 3i times 2i gives me 6i squared. So far we've done this just like we do with any other variable. Here's where your change is going to be. This is where I need you to remember from the very beginning of this set of notes. I squared is equal to negative 1. So right here I'm going to substitute negative 1 in place of the I squared. So I have negative 15i plus 6 times negative 1 gives me negative 15i minus 6. And you can leave your answer just like that. Or if you want to rewrite it so your real number is first and your imaginary number comes second, that's fine too. But either way is fine. Right, so now part B, and this is the last example we've got here. You have a binomial times a binomial. So 2 ways of thinking about this. You can do FOIL, and that's where you multiply the first in each parenthesis, the outside ones, the inside ones, and the last in each parenthesis together and combine like terms. Or if you prefer, you can think of it as double distributive. So we're going to distribute 4 to both of these, and then we're going to distribute 3i to both of these. Either way, you get the same answer, so it's totally up to you. So I'm going to go ahead and distribute my 4, and that's going to give me negative 4 minus 8i. Distribute my 3i, I'll get minus 3i minus 6i squared. Now, I have some like terms here, but then I also have an I squared that I have to replace with a negative 1. So, there's my negative 4. Negative 8i minus 3i is negative 11i. And then I have negative 6 times negative 1. Well, we've got to simplify some more. Negative 6 times negative 1 is plus 6. And now we have like terms here. Negative 4 plus 6 is 2 minus 11i. That is your answer.